Hello, my name is Kim Williams from Kansas State University, and this eGrow presentation focuses on the crop maintenance activity of plant spacing. The quality of most crops is tied to crop spacing. The topics that will be covered in this presentation include the importance of spacing, when to space a crop, patterns of spacing, and methods used to space. Because crop spacing is a tool to manage light that plants within a crop receive, it has dramatic effect on the finished quality of a crop. And because overhead costs are typically assigned on a dollars per square foot per week basis, with square foot representing production area, providing more space per pot adds to the cost of production. But because of its impact on light, spacing directly impacts plant height, shape, and lower leaf quality. Research has shown what growers have observed. The tighter the crop spacing, the faster and the greater the rate of internode elongation. The poinsettia in the photo was grown at inadequate spacing, and the result is a flat-sided plant with chlorotic lower leaves. The importance of a grower's management of crop spacing, because of its direct relationship to both crop quality and cost of production, cannot be overstated. A second and related value of adequate plant spacing is disease management. Air circulation allowed between plants when they are well spaced aids in the management of foliar disease. So, how to know when to space a crop? Thinking about the concept of canopy closure is helpful in answering this question. Though the term is derived from evaluating plant coverage in forests, where it's defined as the percentage of ground area shaded by overhead foliage, it provides a visualization that's useful in greenhouse crop production. In greenhouse production, we think of it as the description of the proximity of neighboring plants and the resulting leaf overlap. Because plants will eventually fill the amount of available space on the bench during the course of their production cycle, increasing the number of plants on a bench will decrease the amount of light that each plant receives when the canopy closes, which results ultimately in decreased dry weight per plant because the plant was able to accomplish less photosynthesis. Therefore, when the leaves of neighboring plants begin to overlap, it's a great indicator of the need to space the crop. An example of plants filling the space that they're given during the production cycle can be observed with this hydroponic basil production process. Plants are started on a tight spacing, as in the back of this bench, which is indicated with the number 1. And then they're spaced twice more as they grow and the canopy closes, as in steps 2 and then finally in step 3, where we see the finished plant spacing and the final harvest size of the basil plants. So, why does plant stretch occur at tighter plant spacings? Well, remember that high amounts of far red light compared to red light will result in internode elongation. The spectral quality of light that the lower leaves can access shifts as leaf overlap increases. You see, plants will absorb most of the red light for photosynthesis, but a lot of the far red light penetrates the upper foliage canopy. And that far red light is just outside the visible spectrum. So foliage on the top of the canopy will intercept red light, but leave a lot of the far red light. So for the lower leaves on a plant, the red to far red light ratio will be lower, and an increase in stem elongation is expected as a result. Therefore, the extent of canopy closure is a really good indicator of potential stem elongation that will occur in the next days or weeks of the production cycle. The spacing of the geraniums in this photo still leaves, as you can see, a lot of room for leaf expansion before needing to worry about canopy closure, so no need to space yet. But that extra space around each pot costs money in the form of overhead costs, and for this reason, growers will often space pot to pot right after transplanting, as shown in this photo, and then space again as leaves begin to overlap. The bottom line is that increasing space per plant decreases the number of plants that can be produced per square foot, and the economics of production inevitably dictate final plant spacing. As in this photo, aisle space is often used as needed, often during the spacing step, to expand production area. It's also important to note that crop species influences spacing. Bulb crops, such as the Asiatic lilies on the left and the Easter lilies on the right, have an upright growth habit that's conducive to tight spacing, leaving only an inch or so between pots. However, the finish, shape, and quality of crops like potted chrysanthemums and poinsettias is dramatically influenced by adequate spacing. As an example, this table provides specifications for potted mum spacing based on different container sizes. Another important consideration for spacing of the same species in year-round or even 9-month production is season of the year. That is, providing a greater spacing in the winter will help make up for the lower daily light integral to which the plants are exposed. Tighter spacing in the summer allows a grower to benefit from the higher light intensity and therefore increased light levels that plants receive. Pot spacing is defined as the distance from the center of one pot to the center of a neighboring pot. So if we space on an 8-inch spacing, there's a distance of 8 inches from the center of one pot to the center of the next, as shown with the red lines in this diagram. A square pattern of spacing involves placing pots in parallel rows in both the short and long dimensions of a rectangular production bench. So any 4 containers form a square. Staggered patterns of spacing result when any 3 containers form a triangle. In the short staggered pattern, which you see on the right, the long rows are parallel to the short dimension of the rectangular bench. Compare that to the long staggered pattern, where the long rows are parallel to the long dimension of the rectangular bench. Decision of spacing pattern is relevant because a staggered arrangement usually allows a significant increase in the number of containers that will fit on a bench as compared to a square placement by about 10% at the same pot spacing. The difference between long staggered and short staggered arrangements is usually less than 3%. Manual spacing is, of course, very common. The downside, though, is the cost to do this step. Here you see workers spacing plants from shuttle trays into their final spacing on production benches. It makes sense to efficiently denote pot spacings and their various patterns on a bench surface so that workers who are manually performing this task can do it quickly and efficiently as they set down the containers. You can accomplish such spacing guidelines such as you see with the shapes on this capillary matte plastic that again provide guidelines for the workers as they're setting out the pots at a given spacing or pattern. And certainly growers can create their own spacing guidelines, such as the circles that have been painted on the wood lath bench in the top photo, or the lines of paint delivered by a boom sprayer, which aid workers in setting out potted crops directly under the boom nozzles for sub-irrigation floor production. Much as we saw with the basil in smaller cells earlier in this presentation, shuttle trays can be used to aid in uniform spacing of larger potted crops. The hydrangeas that you see in this photo are produced pot to pot in the shuttle tray, noted with the blue arrow, and then upon canopy closure, some of the pots are removed from the shuttle trays, which spaces them. They're put into additional shuttle trays, and that results in an optimal final plant spacing. But the shuttle trays provide the guidelines for how to space the plant and uniformly leaving the same amount of space per pot. The cost of spacing manually has certainly driven the automation of this step. In the photo on the left, you see automatic spacing of potted African violets, and on the right, tines to retrofit the spacing machine to accommodate various container sizes. Here's a clever production innovation by one of the industry's leading vegetative propagators that allows for adequate spacing of rooted cuttings during production while saving labor at shipping time. Rooted cuttings are produced in strips that are spaced as you see in the photo, using the tray, the shipping tray, to support the strips. At ship, 6 strips of rooted cuttings are turned perpendicular and placed directly into the tray that had been used for support. So let's end with a quiz. In this photo, you see a sea of hanging baskets. Will they go through the entire production cycle in this configuration? No, of course not. That would be a huge mess. So when do you decide when to space these baskets? Hopefully you're thinking, well, when the canopy closes or the foliage from neighboring baskets begins to overlap. And at that point, how might these baskets be spaced? There are, of course, many possibilities. One of them would be to remove half of the baskets from the floor, leaving a staggered spacing pattern on the floor, and then hanging those removed in basket lines. My gratitude to the Fred C. Glockner Foundation for funding this eGrow University project.